A tank is containing water in the form of a hemisphere. Vertical, the lowest point A, radius R, depth H. At time T, the tank is full. Okay, so flow out at a rate proportional to root H. So we need to show that satisfy the differential equation. So first of all, we need to find dv dh. So this is v. So this is v. This is v. This is v. If you open up the brackets, so we need to find dv dh. We differentiate with respect to h. Pi r is just a constant, so just rewrite the pi r. This 2 goes down 2 times, the new power is 1, so this is the derivative. And for this guy, same thing, 1/3 pi is just a constant. You bring the power down 3 times, so 3 times 1/3 is just 1, the new power is 2, so this is the dv dh. And from this phrase, flow out at a rate proportional to, so flow out means the dv dt is negative something times h, root h. So dv dt is the rate flowing, so the rate of change of volume. It's negative because it's decreasing, flowing out. And the constant, we gotta use b here, so b. And just find dh dt. So dh dt is the same as dh dv dv dt, because when you simplify the fractions, this is actually just dh dt. So dh dv is almost exactly like this, but we flip upside down, so it's 1 over. The dv dt is just like this. So we combine them, we get minus b over. Now for this root h, we want to simplify it to get this form. Just instead of root h in the numerator, we can put it in the denominator, but we use h to the power of minus 1/2. So this is actually the same as h to the power of 1/2, which is the same as root h. Now in the denominator, h to the power of 1, h to the power of minus 1/2, we add the powers. 1 minus 1/2 is 1/2, and 2 minus 1/2 is 3/2, and we get what we need to prove. Now we need to solve the differential equation. From the previous part, we have this. To solve the differential equation, we need to separate the variables. We need everything with h on one side, everything with t on the other side. So we multiply or divide by something. So here we're just going to multiply both sides by this guy here. Because on the left, we're going to cancel out the dt. We have only this. And on the right, we cancel out. We have only b dt, minus b dt. So now we're ready to integrate the equation here, both sides. So when we integrate, this is just a constant. So we are integrating with respect to h. 2 pi r is just a constant. Now when we integrate h to the power of 1/2 dh, we use this rule here. We have the new power is 1 plus 1/2, which is 3/2, divided by 3/2. Okay, well, actually not this rule, this is differentiation. I mean the integration rule. Okay, so the integration rule is from the MF19, the integral of x to the power of n dx is x to the power of n plus 1 divided by n plus 1. So this is the rule for integration. That's why we get from here to here. Same thing here, the pi is just minus pi is just a coefficient or constant, just rewrite it. And if we apply this formula here, h to the power of 2 over 2 becomes h to the power of this over this. Okay, now we integrate b also. So b is just a constant or coefficient. The integral of 1 dt is just t, and we put the constant of integration on one side. Let's put it on the right. So this is actually the general solution of the differential equation. To find the particular solution, we plug in the values of t and h. So from the first part of the question here, we have this phrase: when the time is 0, the tank is full, the depth is r. So when the t is 0, the h is r basically. So we replace the t with 0 and the h with r. So first equation in terms of b and c. So we simplify a little here. Divided by 3/2 means times 2/3. That's why we have 4/3. And divided by 5/2 means times 2/5. And 4/3 minus 2/5, use the calculator, we get 14/15. So in the simplest form, this is the first equation. In terms of c, actually we don't have b anymore, so this is simple, we have c right away. And from the second information from the question, empty means the volume is 0 and the height of the water is 0, so the h is 0. We replace the h with 0 and the t with 14. 0 to the power of whatever is 0 divided by this is 0, this is just 0 basically, and we only have 0 equals minus 14b plus c, so the c is 14b. We already know the c, so this is the c before, so the b is c over 14, but this is the c, we divide by 14, so it's just 1/15 pi r to the 5/2. Okay, we have the b, we have the c. We replaced the b and the c with what we know. So this is the b, this is the c. We have a particular solution now. But now we need to express t in terms of, so t equals something basically. So we can start by just multiply both sides by 15 to get rid of the fractions. Just multiply both sides of the equation by 15. So when we do this, we get 15 times 2 times 1/3/2. So this would be 20. And 15 times minus 2/5 actually. So it's going to be minus 6. And times 15 we have minus 1. Times 15 we have plus 14. So no more fractions. And now let's use, so here we want to find t, so let's divide both sides by pi, so we cancel out all the pi first, and then we divide both sides by r to the power of 5/2, or we can say we multiply both sides by r to the power of minus 5/2. So both sides multiplied by r to the minus pi/2. That's why we have minus pi/2 plus 1, we have minus 3/2. And when we multiply here, we have r to the power of minus 5/2, h to the power of 5/2. And here when we multiply, we cancel out, we have only t. And here when we multiply, cancel out, we have only 14. Alright, and the next step is to add t to both sides. Basically we move the t to the left, and at the same time we move this, or add both sides with this, we move it to the right, and same thing, we subtract this from both sides, we move it to the right. And in the simplest form, we can combine this. So to the power of 1/2 means square root, and minus means in the denominator, so we can use h over r all to the power of 5 and then square root. So same thing, you can stop right here actually, or you can use this form. And same thing here, this is square root of h over r to the power of 3. So that's the final answer. I'll see you again next time.